All right, so again, this problem can be given in the format of f of x equals x squared minus 4. We'll eventually get it equal to 0, but that's because we know for solutions y has to be equal to 0. Okay. Anyway, so I want to factor this. Now, two terms. I'm factoring, right? Two terms. It can be greatest common factor or difference of squares. How do I know if it's a difference of squares? This is like a flashback to factor. I have to stand for this because it's important. Dom, what do you think?
What is subtraction, right?
There is subtraction here. Good. Difference of squares, we have subtraction. What else do we need for a difference of perfect squares? What's up, Ron? Perfect square. Yeah, the first term has to be a perfect square. The second term has to be a perfect square. Class, can you take the square root of x squared perfectly?
Yeah.
What is the square root of x squared? Oh, that's good. Class, what's the square root of 4? Another perfect square? Fantastic. So with this factoring process becomes so easy. X minus 2, x plus 2. Why x? Because of square root of x squared. Why 2? Because of square root of 4. 1 plus sign, 1 minus sign. Maybe I'll put that in colors for you so we can make sure we get that. Here's a plus sign. Here's a minus sign. I forget on batteries if plus is positive and if the positive side is red and the negative side, or like on batteries, yeah, positive is red, definitely, I think. Has a little bump. Well, on car batteries, the red one is the positive. So we're going to go red is positive, blue is negative. That's how you do difference of squares, okay? And now that we factored it, we can set it equal to 0, so we can move straight into the 0 product rule. Sorry, that should have been in different colored ink. Okay, so I see no reason, after these thorough explanations, I see no reason why every single student can't get 100%. At this point, I think it's up to, like, motivation. Well, what do you think? So I factored it. So what is the answer here? All right. Maybe some people can mentally just set it equal to 0 and come up with it. Lucille, what do you think?
X equals 2.
X equals 2 and?
X equals -2.
X equals -2. Okay. If I'm going to translate that into its final perfect form, it's going to be 2, 0 and -2, 0. What's my y-intercept for this equation above? Y-intercept? 0, -4. Okay? That's not a solution. This is not a solution. Not a solution. It's just the y-intercept. We don't call those solutions. Ronan, what's up? You got a question? Okay. Okay. So this is the form I wanted in. All right. Next test, I'm going to be very strict on the form that you give it to me in. What's up? Yeah. Oh, yeah, I got to zoom out a little bit. So you want to see what's not a solution? The y-intercept. Oh, sorry. So you guys didn't see that. Well, that's helpful. All right, but I rewrote it anyway, so we're fine. All right, you guys want to see another one? Solidify even more. What was one of the harder ones for factoring?
I think 7 was hard. I had trouble with that.
7. Okay, yeah, let's do that next. Okay. So for problem number 7, it is a, let's zoom in a little bit on my end so I can get this a little bit bigger. One solution? Okay. AC factoring. So class, this is just standard algebra 2, okay? You guys must be good at AC factoring method, and that's what's needed here, okay? Is this a question on this? This is number 7. I skipped it because I wanted to go towards more what you guys had questions on. So, yeah, go ahead. Okay. So AC factoring, how do I know it's AC? Well, there's 3 terms here. Okay, 3 terms. And it goes from like an x squared term, an x term, and a linear term. Okay? But obviously if there's 3 terms, there's going to be one of each type. Okay? So how do I do this? Well, I have to multiply A times C. I need to multiply A times C. What's 3 times -30? -90 is correct. What are factors of, oh, this is going to be tricky. Well, hopefully you guys did the homework so you can help me out. That multiplied to 90. Negative 18 and 5?
Yeah.
Negative 18, okay. Negative 18 and 5. When you multiply them, they do give you 90, negative 90. When you add them, you get, when you add both of these quantities, so I should put a plus sign here, equals negative 13. So that checks out. So now what do I do with that? Now we've seen this for maybe the 10th time. Okay, so if you still don't know it, pay close attention now. All right, I multiplied A times C, got the negative 90. I found factors of C that add up to my B value, right? Why do I need this to be 18? Because this has to match that. That's my B value there. Maybe I'll put those in different colors. So this number here has to match this number here. Okay, so now I'm going to rewrite and make it 4 terms instead of 3. All right, my 4 terms are the following. 3x squared minus 18x plus 5x minus 30. There are other ways to do this, but I really suggest doing it this way. This is the cleanest way, the way that makes the least mistakes. Okay? And now I want to do the greatest common factor, factor by grouping. I'll use colors again because I know you guys will get, like, get that color stimulation and attention to it. That's one group, that's another group. All right, red group, I'm going to continue writing in red. What's the greatest common factor of 3x squared and negative 18x? I would say 3x. 3x, and what are we left with? X minus 6. Okay, my next group, I'm going to do it in blue. What is the greatest common factor of 5x and negative 30? I'm going to say 5 plus 5 times what? Surprise, surprise. You shouldn't be. If you're surprised that we got x minus 6 twice, you didn't know how to do this process earlier. Okay, of course we should get the same thing inside. That's going to help us for our regroup. So I'm just going to do this part in regular ink. 3x plus 5, because those are both of the outside regions. And then x minus 6, because that's the same inside region for both. Okay? Now, are we done yet? What's up, Lisa?
Sorry, over here. We multiply 3 and 30, and that's when we factor into the other two.
Yes, 3 times negative 30 is negative 90.
And you have to get to the middle term.
So yeah, these two terms you multiply to get this magic number. This magic number, we have to find factors that multiply to it that add up to the middle number, negative 13. So you guys can see that again. Okay, so I'm not done here. I still have to set it. Remember, we're trying to find solutions where it's on the x-axis, where y is equal to 0, and set this equal to 0. Set this factored form equal to 0, which means I'm setting both parts equal to 0. Equals 0. So that means 3x plus 5 equals 0, and x minus 6 equals 0. Solve for x. All right, what were the two solutions you guys got? Are we unsure how to do this, right? 2? That's a 6 down here.
6 minus 6.
Wait, what? I'm confused what you're doing. All right, let me continue to go through this. Solve for x. So for the top, let me just erase this bottom one for now. Okay. Minus 5, so you have 3x equals negative 5. Divide by 3, divide by 3. X equals negative 5/3. That's one solution. The other one was x minus 6 equals 0. X minus 6 equals 0. Add 6, x equals 6. That's my other solution. But I want to put it in a form that makes sense. So negative 5 over 3 comma 0 is one solution. And 6 comma 0 is the other solution. That's where it crosses the x-axis, twice in this case. Okay, I think we get it. Do we get it, class? Okay, awesome. Now, I'm not going to give it to you in these more complex forms, but they just want you to do subtract 5x from both sides. So you get 2x squared minus 5x equals 0. Okay. And then you do GCF again, like one of the factoring methods. This one is GCF. No, I don't want to. I don't want to take it that far. They just show you different forms. Oh, this was pretty wild. How'd you guys do with this one? Let's solve number 11. Just because I assigned it, so I want to go over it. Or what's the hardest one that I gave you guys? Which one do you guys want to do? 15 looks pretty bad. Let's do another AC factoring. Okay. Let's go to 15. All right. So you just want to make it all equal to 0. Right? The first ones were equal to 0. It was much easier. These ones you want to set equal to 0. So we subtract x squared. Actually, let's ask you guys. Do we know? Do we know? All right. How can I make it equal to 0? Think about this. Yeah.
By moving like the x squared minus x over.
Okay, so how can I do that algebraically?
Subtract x squared 2x squared.
Subtract x squared from both sides. I wanted the proper term. So you were right. What you're saying is right, but the way you said it was wrong. You're subtracting x squared from both sides. Okay, cancels here. 2x squared minus x squared is just x squared. I'm going to rewrite everything else. Why would I make a chance on making a silly mistake? Rewrite everything else. Okay. What do I do next? Not subtract x. Add x to both sides. It's good to get this refresher in, but really by the end of Algebra 2, you need to be a master at this. A master at isolating equations for either a variable or 0. Like even if you get through my class and manage to pass, and you don't know how to isolate a variable or isolate something, don't tell people you know Algebra 2. Don't tell them that, because it's not true. If you don't know how to isolate a variable, which is right here, but by the end of the year, so you still have some time to master it. Okay, add x to both sides. X squared minus 8x minus 65 equals 0. Oh, that's annoying. Factors of negative 65 that add up to negative 8. What do we think, class? I know 12 times 5 is 60, so 13 times 5 is 65. Oh, that works. 13 and 5. Yeah, x minus 13 and x plus 5, yeah. Do you guys know how I did that mentally? 12 times 5 is 60. So how can I get to 65? I need 5 more. So 5 times 13. Mental math skills, yeah.
So does this become C factoring?
This is just C factoring here. I thought it would be AC, but it wasn't. Yeah, because there was no A value, right, Amelia? So I could have done AC factoring here, but why would I? It was just easier to do the C factoring. Okay. I thought that would be, oh, this one will be AC factoring, 17. Okay, let's see that one. Okay, how do we isolate this? I want everyone to look at this problem up front. Right? Everyone to look at this problem on the board. Patrick, why don't you face forward and not sideways? Okay. I want you to think about, I'm going to tell you, but I want you to think about it. What's the first move to make it equal to 0? Think about it. Dom, what is it?
Subtract 2x squared.
I could do it that way, and it would be, but there's still 2 steps.
Subtract x.
I'd rather keep this term positive personally. It's a personal choice. Dom, think about it this way, because this way might make it a little bit easier. But that's totally fine that you can do it that way. Subtract x, subtract x. So 2x squared minus x equals 21. It's just the thing about keeping the highest degree term. Keep that as like your basis. Like I want to move everything to where, and the highest degree is the x squared. So I'm like, that's my rock. That stays. Let's bring everything else over. And it keeps it positive at the end of the day, so I don't have to deal with like multiplying by negative something later on. Anyway, minus 21, right? Did we all think about that? Minus 21. 2x squared minus x minus 21 equals 0. Okay. I hope by now you guys, every single student in this classroom, can do AC factoring and figure out what the first step would be. What is every single student thinking about right now is the very first step? Patrick, help me out. It's equal to 0, but then what do I do after it's equal to 0? Do we know? It's okay if we don't, but by the end of this problem, me going over it, I want everyone to know. Amelia, what do I do?
You multiply A and C, so 2 times negative 21.
A times C. Everyone should be thinking A times C right now. Why? Because it's AC factoring. There's 3 terms. There's an A value here. So I get negative 42. And by this point, I would hope, like, we're all getting to the point where we could all kind of figure out what's going to happen next. I need to find factors of this number that add up to negative 1, because that's when it's in front of the B value. Remember, I circled it in green last time. That's the magic number I need to get over here when I add these two numbers together. So what's factors of negative 42 that add up to negative 1? 6, 7. Yeah, it is actually 6, 7. All right, so we're going to have to use a negative 7 and a positive 6 to get to negative 1. It's crazy. It's crazy the number of times 6 and 7 get involved in problems. I can see why it became a thing. Probably due to the number of times the answer is 6 and 7. Okay. Anyway. So I'm going to rewrite this now as... Wait, hold on. Do we know? Do you guys know what to do next? Ronan, what do we do next? I would hope, like, every single person really should know, because I've explained it so thoroughly. The 4 things. Good job, Ronan. The 4 things is correct. 2x squared minus 7x plus 6x minus 21. That's still equal to 0. All right, 2x squared minus 7x plus 6x minus 21. Maybe you guys remember the colors of what I did next after that? You're going to do greatest common factor here and greatest common factor here. Some people are paying very good attention. If you guys don't know this, then pay attention now. I can only explain this so many times. Okay, what's the greatest common factor of 2x squared and negative 7x? Just x. So I'm left with, oops, I meant to do that in blue. Whatever, we'll just use black. X, and then you get 2x minus 7. Do we understand why it's 2x minus 7? I just moved an x out of each term. Okay, Ron, what's up?
Could you put the 6 with the tip?
I could have. It doesn't matter. I just wanted, and I was thinking about that because I was like, it'll be easier, cleaner numbers to factor out. But I thought, I want to show them it doesn't matter, so I'm going to put it in the most awkward way possible. It'll work out. Greatest common factor of 6x and minus 21? 3. Yeah, just a 3. Plus 3. It's a positive 3, so I'm going to put positive 3 there. And I'm left with a what? Surprise, surprise, but you shouldn't be. Bless you. All right. So now I'm going to do my rewrite thing where I take the outside things and put them together, x and a plus and a 3. And the inside things and I put them together, a 2x minus 7. And set that equal to 0. Okay, I got to erase some of what's going on down here. Oh, I don't even have more room. It's a shame. Alright, so if x plus 3 equals 0, let's try to do this a little bit quicker. I mean, yeah, we could set them up and solve them, but if x plus 3 equals 0, what is x equal to? Negative 3, right? So x equals negative 3 for the first one. Can you guys do the second one mentally? Armani, you're good with mental math, man. Come on, help me out. 2x minus 7 equals 0. Mental math it for me. Make x equals what? This part, right? 2x minus 7 equals 0 in your head. What is x equal to? Do that mental math for me. 5? 2 times x minus 7. Come on, man. Think about this. I know you can handle it.
You're saying 2 times something.
2 times x minus 7 equals 0. I'm going to add 7 to both sides. So we got 2x equals 7. And then I'm going to divide by 2. 7 over 2. 7 over 2. No, 7 over 2, not 7 times 2.
Could we also put that as a decimal?
I'd rather a fraction, honestly. Minus 7 equals 0, which means 2x, we add 7 to both sides, equals 7. So I'm losing space here, but x equals, I'm going to divide by 2 on both sides. X equals 7 over 2. 7 halves. No? I think you could have handled it.
I would have got it eventually.
No, but just I think you were trying to just find the number. I just wanted you to like move stuff around in your head, you know.
Wait, can you just scroll up so I can see the answer?